Okay, I want everyone to breathe a little sigh of relief. We've moved past trig ratios of obtuse angles and supplementary angles. We can take a break from that for a while. Come back to it mid-chapter quiz. We'll see it again on the unit test. Obviously, it'll be on the exam, but for now, we can just have a bit of a break from some of those challenging concepts. The sine law, pretty straightforward. This is a review topic, so we're going to go through this pretty quickly. Here's the formula. It actually has two forms. It applies to any shaped triangle. I really don't recommend students use the sine law for a right triangle because you have sine ratio. However, what you need to know is in let's say an acute or an obtuse triangle, when can I use the sine law? So we need to know information that would look like the following. Two sides and one non-included angle, or the measure of two angles and one side. So the main thing here is that we have a matching pair of side angle. So we either have, say, this angle here and its opposite side known, or possibly we have two sides known, but at least we have an angle and a side that correspond. That's really important because the formula actually has three parts to it, and whether we use the first two, or whether we use the second two, or whether we use the first and the third, we have four unknowns, or four variables at least. Three of them have to be known in order for us to solve for the fourth. Okay, so in these examples, well, you may have gone through an investigation in class at this point, depending on when you've viewed this video, and just to confirm that the sine law formula actually holds up for different types of triangles, acute and obtuse. We'll go through an investigation as well to see how we can use it to solve for, again, some inaccessible heights. So this poorly drawn diagram is sort of a three-dimensional view of maybe the inside of a mountain, or the approach to a mountain where we have some distances known and some angles that have been measured, and we might want to solve for the height of the mountain. We can use sine law as well in this problem. So this worksheet we'll do in class. We're also going to derive the sine law, and it's not too difficult to derive, but we'll do that in class. For this video, I just want to focus on some examples. So the first two examples are going to have information provided but no diagram. So I want you to just think about how you would draw this diagram. I'm going to set up and I'll show you the solution and I'll explain it. Okay, here's our diagram. What I would suggest when you draw these is start out by just drawing the angle that at a particular vertex, and then decide which of the other two vertices you want to label H and which one you want to label K. But of course, relatively speaking, HJ is shorter than HK, so you want to try to represent that a little bit in your diagram. For the most part, the solution from this point on is just mechanical. It's just calculations. Use the formula of the sine law. In this case, we're looking for an angle. So what I would do is I would write out the sine law as it would apply to this triangle. I would write sine J over J equals sine H over H equals sine over H equals sine K over K, angle K over little k. Label what I know. Little k is this, little j is this, little h is this. Clearly don't know either angle h or angle k. So I can't use the middle ratio in my solution. I'll have to use the first and the third ratio. Okay, and in this case I would just substitute in what's known. So sine of 75 all over 10.4 equals sine of angle K over 8.3. And probably the easiest thing to do there would be to multiply both sides by 8.3. And at this point, I'm not really working out anything on a calculator just yet. I'll leave it in this sort of exact form. Multiplying the right side by 8.3 would give me sine of K. And then once we've evaluated probably the decimal form of this, we could apply the inverse operation, but I'm just going to show sort of in one big picture here, this is the overall calculation would be sine of 75 degrees divided by 10.4, take that result, multiply it by 8.3, evaluate the inverse sine of that, and you'll have your answer. Okay, in example 2, similarly our triangles DEF, we have two angles and one side, and we're actually looking for the length of a side. Now here DF is comparable to little e, so let's again think about the information given, draw a triangle, and then label it and solve. Okay, I worked out the previous example, got 50 degrees, just if you were looking to confirm an answer. Okay, so let's go back to our example 2, draw on the diagram. We have two angles and we have a known side, and in this case we're trying to solve for df, which would be little e, so this is our unknown. Now in the case where we have two angles and a known side, again we're looking to try to match information. By that I mean we would really want to be matching side F with angle F. So let's first solve for angle F. It's going to be 180 subtract the other two. They total 105, so we'll have 75 degrees of angle left in our triangle, so that would be angle F. So we can label that in there. And at this point, we can write the sine law for our formula, matching the triangle. So we have, now what I would do here is I would use the form of the sine law that has unknown side in the numerator. So I'm going to put little d over sine d equals little e over sine of angle E, and I'm going to put little f over sine of f. And then when we substitute our unknowns, we're going to be using this ratio here. And in this case, we need to use this ratio here because the unknown is little e. So we have little e over sine of its corresponding angle. Opposite little e is 59 degrees, and that would be 9.8 over sine of 75. And again there, to solve, multiply both sides by sine of 59. And that will give us our unknown side. Okay, there's no limits on the answer. I get 8.7, and I think we're in centimeters here. Okay, let's keep moving. Next example. Okay, in this case, example 3 is almost exactly the same as the previous example, except we do already have an angle and a matching side, so that works well as one of the ratios. Now in this case, we're trying to solve for the length of D, which would be this side over here, which fits nicely because it matches angle D, so we can simply write D all over sine of D equals, and keeping in mind here, we don't need angle F or side F, so I'll just omit that from our sine law formula. We'll write E over sine of E. So write the formula, then write what you know. D is unknown, sine of its angles, sine of 40 degrees. E is 38 centimeters, its angle is 95. Okay, now just take note here, we looked at the trig ratios of obtuse angles. So sine of 95 degrees, you don't have to panic and think, oh boy, what am I going to do with sine of 95? Is it going to be positive or negative? It'll be positive. However, there's another angle which would be 85 degrees, which would have the same trig ratio. So really, you can be at ease about how the math is going to play out, but there would be another triangle that we could draw that would have similar information, but an 85 degree angle instead, which would be an acute. So when I solve this, again, I'm just going to multiply both sides by sine 40, and then evaluate my answer. Okay, I get 24.5 centimeters. Keeping in mind that in a triangle, the biggest angle, which in this case has to be the 95-degree angle, is going to be opposite the biggest side. And the third angle, which we're not given, would be 45 degrees. Okay, because 45 and 40 is 85 and 95 is 180, so 45-degree angle. So compared to the 38 centimeter side, the next longest would be this one, and then the shortest would be side D. So we can be certain that side F would be somewhere between 24.5 centimeters and 38 centimeters long. Okay, so we're going to keep this video on the short side, give everyone in the class a break from some of those longer videos in section 1.3. Here we're just looking at, again, one angle, one unknown side length. So what I'd like you to do is to pause this, just do a quick calculation in your notebook or on a scrap piece of paper, and then I'll show the full solution and you can compare your answers. All right, in this example, I'm going to scroll up again, show you the information that was provided. Notice that one of the lengths is in feet and inches, and that is pretty common. It's not set up so you always have to convert this just to make you do that. But when you do use a measuring tape, quite often we'll measure in feet and inches. But it's easy to convert to a common unit, so I'll use the smaller unit inch. In this case, I'm showing the conversion. 2 feet is 24 inches. Again, show your given quantity, multiply by the appropriate rate, convert into the desired quantity, feet cancels, and then of course simple matter of adding 24 and 2 to get a total inch length. Angle Z is simple. In the triangle there's one angle missing, so 62 degrees is that missing angle. And then I write my sine law formula. I'm going to take, in this case, two different forms of the sine law. I'm going to take the first and the third ratios together in solving for x, and then in solving for y I'm going to take the second and the third ratios. And that's the nice thing about the sine laws, is it actually has 3 different ways you can combine the unknowns. Same calculation in both cases. Just notice that what I did in solving for y is I went back and used the information that I knew for z, because that was exact. So rather than relating y and sine y to x and sine x, where x is known only to, say, the nearest tenth, I just used the exact 26-inch length for z and the exact 62-degree angle, and both answers are rounded to the nearest tenth of an inch, so which probably is more than we would need. The final example here I'm going to do in class with the group, so I'm going to not include this one on the video, but if you want to work this one out, you can come in and see if your diagram matches. Again, here we're using angle of depression, which, as we reviewed before, was relative to the horizontal. All right, and just one final note here: if you're working ahead because of absences or anything else, tomorrow and probably the next day we'll be looking at assigned questions on pages 32, 33. I'll be collecting number 16 on page 33, and look at that, we're just a little bit under 15 minutes, so enjoy the short videos while they last. See you tomorrow.